All right, so let's move on to the next thing. I want to cover input and output like we did before. Remember how we read in information from the user? We prompted them for information. We're going to make a couple little changes to that, and we're going to show how to read multiple lines of data from a user. So I think we have file.txt here. There's nothing in there. That's not great. Let's go ahead and just add some stuff to file.txt. Doesn't have to be much, just, foo, bar, baz. There we go. That looks good. And so we're going to make a script called read input. So read input, like all our other scripts, will start with the same little shebang at the top here. Save it, chmod, +x, read input. People on my YouTube channel get upset that I run this over and over again. They're like, you should just have a script that automatically creates the file and makes it executable for you. Maybe I should, but you know what? I don't mind writing it over and over again. You get kind of used to it. So let's go ahead and let's read some data in, and we can just say echo, you said $foo. Notice we don't have the P here. We're not going to prompt the user, so this is not going to be that nice of a program. We're just going to know that it's asking us. So if we run this, that's not what I wanted. If we run, read input, we can see that it just hangs. It hasn't prompted us for anything, but it is waiting for our input. So we could say hello, and then it'll say, you said hello. Cool, that makes sense. Read input's very simple. It just looks like this. There is some weirdness with read, specifically around when you give it some backslashes. So if I were to say like, hello, \n world, you can see that it says you said hello n world. So it tried to interpret this. That's kind of weird. It can lead to some weird behavior. So what I like to do when I use read is I pretty much always give it the -r flag. So almost anytime I use the read command, I'm giving it the -r flag. If we look up the help page for read, we can see there's a lot of stuff here, but don't worry, -r. Do not allow backslashes to escape any characters. So basically you can think of R as like raw. It's just going to read in raw input. It's not going to do any backslash mangling. So if I said hello world, it gives me back the literal string with the literal backslash in it. So this is the truest thing to what the user has given us. And I like that. So let's go ahead and show this. So we have our, read input. We can put whatever here and it will just print it back to us. We could also echo whatever and pipe that into read input and we get the same thing. Hey, that's pretty cool. What if we did something like a really big file, user share dict words, remember this giant file, and we pipe that into, what do we call it, input? Read input, I already forgot. Pipe it into read input, what's gonna happen? We only get the first line. Read only reads the first line. You can modify that behavior by changing the delimiter character, but by default, it only reads line by line, and it will only read one line. It successfully read one line. There's more data waiting for us to read. We just never read it. So let's go ahead and make this read all of the lines. How can we do that? Well, we can take this thing and put it in a while loop. Remember how I said you can put commands in an if or a while statement? You can just do while read. There we go. We can change the name of the variable from foo, let's call it line. So while read line, someone would call this, I see this referred to a lot as a while read line loop. That's what it is. So we put our semicolon here, we put our do, that's how we start the loop. We put our done, that's how we end the loop. And we can put whatever body we have here. I'm gonna give you a quick little tip about bash. If you don't fill in this body, if you don't put anything in there, it's invalid. So you will get an error that is considered a syntax error. So if you're used to Python, you would have like the pass command. In bash, we can do true, or some people might even do a single colon. Single colon is just a command that does nothing. Bad example because it's just gonna hang and wait for, it's gonna have to go through and process that line by line. But the single colon is just like the command true. You can do help colon, null command, no effect. This command does nothing, always succeeds. So pretty simple command built into bash. You'll see it used a lot. But now that we have this, let's go back to our read input command here and let's echo we read line $line. So let's go ahead and rerun that. Where's that? That cat pipe into read input. And as you can see, it's going through line by line and reading the data. So right off the bat, do you notice something? It's significantly slower to process a file line by line in bash than it is to just run it through cat and maybe pipe it to something else. So be mindful of that. Bash can read things line by line, absolutely. And it's not slow at it, but when you compare it to other tools, like if I were to pipe cat to grep Dave, very, very fast. If I were to go into this example and check like if line equal Dave or something like that, very slow. So just something to keep in mind there, but this is how you can read it line by line, and we can process it, and we can do processing on the lines one at a time, which is pretty neat. And again, there are a couple little gotchas with this. Notice that the read command is the condition of the while loop. This means while read is successful, meaning it was successfully able to read a line. This can be problematic if your data does not contain a new line. So let me show you what I mean. If I echo hello, it prints hello to the screen, but there's also a new line here. Notice that the prompt is on the next line. That's because it's part of the echo command. If I pipe this to something, let's say pipe it to cat minus v. Actually, cat minus v won't show us. Is it viz? None of these commands show us. These are not what I'm thinking. I'm going down the wrong path here. Let me back up. Let's pipe this to hex dump. Or on your system, you might not have hex dump. You might have OD, or you might have XXD. So there's a lot going on here, but all of them are basically the same. I may have lost you, but don't worry. We're just going to look at echo hello, and then echo hello pipe into XXD. And we can see that we have hello and a period here. This period is a character, but it's not actually a period character. Hello, H, that's 68 on the ASCII table. E is 65. LL, 6C, 6C. O, 6F. And then this one right here. This is hex 0A or decimal 10 or the Newline character. I bring this up to let you know that when you echo hello, there actually is a secret byte there, and it's the Newline character. So that's why you're getting that there. And that's why when I pipe it into read input, it shows up as its own line. If I were to suppress that new line, I can do echo minus N hello. Notice how the prompt is on the same line as hello. There's no new line there. If I were to take this and pipe it to XXD, notice that the 0A character is missing now. If I were to take this and pipe this into read input, there was nothing. It lost that data because it didn't read a new line. That's because this checked that it was successfully able to run it. There are little tricks you can do. I've seen people do this where they say -n line. Basically, this is saying while we were able to successfully read this line, or the line variable has some data in it, then we can do that. So this is good because it will work because we were able to read the line. There wasn't any new line there, but just be mindful of this. If that's gone, we're going to read up to the next new line. So if your data does not end in a new line, it's going to be lost. But let's go back to our first example here. We have user share dict words. We can pipe that into read input, and hey, it works. This is the same effectively as running this. Let's go ahead and read input. Remember how we wrote data out to a file before? We can do the opposite. Okay, instead of greater than, we can use less than, and we can tell it to read in from a file. So we could put the name of the file here. What's the name of the file? User share dict words, and this will be the same thing. There is a slight difference here. Some people will note, if you've seen this before, this would be called a UUOC, a useless use of cat. There's nothing wrong with this, and in fact, when you're learning, I think it's super useful to see it this way. Pipelines are really useful. This is slightly different. We don't fork out the external cat tool. So remember, cat is an external tool. It exists on your system. We're not forking out cat and piping it to read input. There's no cat at all. We are just telling bash, our shell, to read in this data and give it to read input. So bash opens this file, bash hooks this file up to read input, and then bash runs read input. That's basically what happens there. Same effect, like effectively it's the same. I have a video where I talk about the useless use of cat and all different things about this. It's a rabbit hole. So again, like I said, it'll be mentioned in the references. You can check it out in your own time if you want to. So yeah, you can have this. Also, fun little fact, this syntax can be anywhere. So you could put it at the beginning like this. If you're like, oh, I like my file on the left and this on the right, you can do that. That's totally valid. Some people also don't put a space between the two. So again, this is also valid. It totally works. It's just up to what you like in your own personal preference.